Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I'm pleased to welcome Sebastian Andreassen as my guest. Sebastian is the Chief Commercial Officer, Director and Co-founder of Cembrane, the world's largest producer of silicon carbide membranes for OEMs and system integrators within water and wastewater treatment. You know, tectonic plates are moving right now in the water industry, and Sembrine is no exception to that state of things. They got acquired a couple of months ago by Ski on Water through its subsidiary of Vivo. That move now places the company on a faster track for growth, doubling its production capacity and ambitioning, to quote Sebastian, to take the North American market by storm. As this kicks off their second leg in their entrepreneurial journey, let's review the first section, who saw a father and his two sons build in 7 years a leader in its sector with references in 65 countries that leverage an expensive material to reduce water treatment costs. How? Well, Sebastian will tell you in just a minute. But right before, let me tell you that preparing these podcast episodes is quite a time investment. To investigate the path of my guest, to craft some questions, record, cut, summarize an infographic, design some quote visuals, or update the Don't Waste Water website. I love doing it because I appreciate how much I've learned discussing with all of these incredible guests. Now, if you enjoy it too, I'd be grateful if you could help a bit by spreading the love. Just take that episode wherever you're listening to it and share it with 2 of your colleagues or friends. Please do it, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Sebastian. Welcome to the show.
Thank you. Hi, Antoine. Thank you for having me.
Well, I'm really excited to have you because I have a full plate of topics which I'd like to discuss with you today. But, I have traditions on this podcast, so I'm going to open with a tradition, and that's the postcard. So you're going to send me a postcard from Lunge, and I'm pretty sure I don't pronounce that one right.
I would say it's close enough. It's pronounced Lunge, so it would be workable if you said it the way you did it, if you came to Lunge and visited me. And you should definitely know about the producers of silicon carbide membranes. There's one called Sembrine. This is where I am right now. Honestly, it's an industrial type of city. There's a nice golf course and a nice place to have a good lunch. Otherwise, I can't speak much to the city.
You mentioned Silicon Carbide and you mentioned Cembrane. I'm pretty sure you have a link with that company. We'll come back to that. But for the one that wouldn't know where where that city is, it's next to Copenhagen. So you are in Denmark. And I had Harris Kadrisbeek from Leaktech on that microphone to discuss Leaktech. You've been at Leaktech as well. I was wondering what's special about Denmark when it comes to silicon carbide membranes and ceramic membranes in general.
Yeah, that's a good question. And you're right. I know Harris from Leaktech, and I used to work there. I think it happened by chance. Back in the 90s, there was a company called Notox that thought of an idea of using silicon carbide to produce filters for the automotive industry, to clean the exhaust from cars and trucks. And they had, limited success, but there were a group of guys from that company that then started Leaktech in the year 2000, roughly, whether it was 99 or 2001, I'm not quite sure. And they wanted to put a membrane on top of this filter that was used for the automotive industry. Mm-hmm. And they wanted to do it in silicon carbide. That's why the name is Leaktech. It stems from liquid technologies. So there have been some spin-offs around that early beginning. And today there are at least 3 companies working with silicon carbide filtration in different ways in Denmark, which is a small country with only 5.8 million people. So proportionally, there's a big part of the population working with silicon carbide membranes.
So you mentioned Sembrine, and I was joking that you might have a link with that. Sembrine is somehow, historically was at least, your family business. What's the history of Sembrine?
The history of Cembrane, we were started very early in 2015, roughly 7 years ago. It was founded by me and my father and my brother. We all have a history working with silicon carbide. Me personally, I've worked with silicon carbide product and business development for almost 15 years. We started with the aim of taking this fantastic, marvelous material called silicon carbide and wanted to turn it into a flat sheet membrane. And the idea or the vision behind it was to make membrane treatment simple and economical. Membranes have a bad rep in the market of being a pain in the behind to operate and very expensive and complicated. And
You mean membrane in general or ceramic membranes?
no, membranes in general, especially polymeric membranes, which the market is dominated by polymeric membranes that are very sensitive and can clog up very easily and all these kind of things. So, but we had a vision to use silicon carbide and make membrane treatment economical and simple. The only problem is that silicon carbide is very expensive. It's very costly and at that time not economical to use outside of very extreme applications. So that's how it started. That's why we started the company. And perhaps we'll get into the rest of the history during our conversation.
So you see a material which is very expensive, hard to adapt to water, and you think, hey, that's the one I need to build a business around. Sounds weird.
Yes. I don't know. It was very natural for us. For me, it was all I knew, silicon carbide, and I'm an engineer. My brother's an engineer. My father's an engineer. So we were very, if not entirely, focused on this product, and maybe less so on the more commercial aspects, but somehow taking these amazing attributes inherent to silicon carbide in water treatment, and then finding a way of industrializing the products and reaching economy of scale so it becomes economical to use and adopt into the water treatment sector.
So let me give a spoil into what we will be discussing at some point in our discussion, is that it used to be a family business, if I'm right. Now for a couple of months, it's still the case, but with a new owner, because you've been acquired by Vivo, so by Ski on Water, to please my partner in crime, Björn Otto, who keeps referring to Ski on Water in every second sentence he makes. We'll come back to that. I'd like to understand the path before that. Today, I think you're still the chief commercial officer, right?
Yes, I am. You're right. We were acquired in June of this year by Ski and Vivo, and we have continued the same management as we were before that. So I'm still chief commercial officer in charge of commercials, sales, and business development.
So let's take that eye now for a second on the market. So you're the chief commercial officer, which means if you want to sell something and if you want to promote your solution, I guess when you started Sembrine, it must have started with identifying a problem. You cannot just come and say, I have a solution if there is no problem. So what was this water challenge or water industry challenge that you wanted to take on, and how did you do that?
You're right. The problem was the fact that the water treatment market for the use of membranes was completely dominated by polymeric membranes. And I've seen a number of these plants. I've seen all the complications associated with the use of polymeric membranes, and also the sustainability aspect of making a lot of plastic and throwing it away after a couple of years. So that was the problem. And we were convinced that silicon carbide was a big part of the solution of making it more simple to use a membrane, making it more economical, which is kind of a paradox, right? Taking a very, very costly material and believing that you can make membrane treatment less expensive.
Sorry to cut you, but let's discuss this simplicity just to understand what's so complex about a polymeric membrane.
You need to take a lot of precautions in the pretreatments. You need to be very careful the way you operate the membrane. There are a long list of restrictions that they cannot endure certain elements coming into the membrane that will deplete it or destroy it. And when you inevitably will have fouling or scaling or dirt sticking to a polymeric membrane, you're also very limited in your ways of cleaning it. You can only use a certain amount of chemicals, a certain number of times, and often to some degree you destroy the membrane whenever you clean it. This adds a lot of complexity and nuisance around the use of polymeric membranes.
To understand this pre-treatment, you mentioned so a polymeric membrane would need a pre-treatment before it. Do you totally eliminate that need with silicon carbide membranes?
No, we don't. It depends. It's very dependent on what application we're talking about, right? Is it a wastewater application? You can have biological treatment up front, coagulation, or other types of pre-treatment methods. But you need to have extensive screening, more extensive screening up front, which adds a level of complexity to a plant. You need to limit oils or solids coming in to your plant. And you have a difficulty managing upsets in the water that's coming into the membrane, where silicon carbide is much more resilient and able to absorb volatility in the water quality coming in. So that means that for a polymeric membrane to operate, sometimes you need a DAF unit up front to make sure you have a steady flow of solids concentration, or a clarifier, which in many or some cases can be eliminated by silicon carbide.
You mentioned the applications, and you said it depends on the application. If we go back to the beginning of Sembrine, so you have this belief that your silicon carbide material is going to be the game changer, but still you have to deal with the fact that at that point in time, it's still pretty expensive. What is the first application you picked?
It was drinking water. It was born out of the wish to provide clean water for drinking water purposes. Maybe from a more romantic motive, seeing water. It's extremely satisfying treating water for drinking water purposes, I feel personally. But we have also done a lot of wastewater treatment. I think a little bit more than half of our install base today is wastewater treatment, both municipal and industrial wastewater treatment. And the rest is drinking water treatment.
So the base application was this drinking water, then you diversified a bit. What I'm interested to understand, you started, and maybe that changed over the time, but right now what you do is that you have this material, you have the module, and you're marketing both of them. Is that the shape you always had, or at the beginning did you have to do more or less? Or what decided you to say the sweet spot in this full vertical is to say we do the material and the module?
When we started, we were very, we wanted to focus as much as possible on what we are good at, and that's the production of silicon carbide. So ideally, we only wanted to do the silicon carbide membrane and nothing else. But we quickly realized that a lot of our customers were saying, okay, this is your silicon carbide membrane. What are we going to do about it? Oh, yeah, you need to figure that out. And in most cases, that didn't turn out very well. Some turned away, and some that did say, okay, I'll try to do something. And they didn't succeed and made the membrane look bad. So that's why we decided, okay, we need to control that and adapt or develop our own module. And offer that as well. So that is our key product to offer a complete module to the market.
Have you ever tried to go the next step up on the ladder and to say, I could become an integrator?
Absolutely not. That will not happen. I'm of the firm belief that you should focus on what you're good at. And I mentioned earlier that our vision was to make it the preferred technology for membrane treatment. That means a lot of scaling of the technology has to happen. I believe this happens in layers. So we focus on making the silicon carbide better and better and less expensive to manufacture. And then work with a long range of OEM companies that take this product and innovate around it and make it perform to its fullest. And if we started doing that, it would be equivalent to having one OEM customer, and it would be very difficult. It would put a hindrance to scaling our company and expanding the use of the product. A lot of the maturity happens around the silicon carbide membrane and bringing down the cost, but I think most of the potential moving forward is around the use of the product, making it more productive, finding new ways, hybrid methods of removing micropollutants or other substances. So there's a new world that needs to be explored by others that are much better at that than we are. We're not experts in building plants, and there are a lot of companies that are good at that.
Okay, there's a lot to unpack in what you just said, so I'm going to put two questions in the fridge. So I'm coming back in a second on what you just said about this hybrid and the process element of removing new substances, and I'll come back to the OEM point. But you also said at the very beginning, there's this element of the curve of the cost of the silicon carbide, and you're working on trying to improve that. I was just looking at some studies preparing our interview, and I found an interview from you where you say that between the moment you started Sembrine and now you divided the cost by 10. And the study I found was showing that between 2000 and the moment you started Sembrine, the cost was already divided by 10. So that means that since the 2000, the cost of silicon carbide was divided by 100. So is it like, this kind of Moore's law or Heights law, and it's going to keep on that way and that pace? Or is there just a physical limit at some point which says it's not possible to divide the cost by 10 every decade?
Yeah, I don't think we will follow Moore's law, unfortunately, but I don't believe there's a limit. There's no limit to human ingenuity and to innovation. There will always be ways of improving the product and the performance and the cost. Of course, on our current setting we have now, there are some limitations, but there will be new ways of doing it in different ways that are smarter and more effective. I cannot point to single elements this thing came down tremendously in cost, and that is why we are at the cost we are today. It is the sum of hundreds of things that has brought the cost down over time. So every aspect of the production has improved incrementally and brought us to the point where we are today. So to be fair, in you mentioned 2000, there was, I would say, lab scale at best. There was no industry at all around the use of silicon carbide filters or membranes. So there's one aspect of your own production where you can do a lot of improvements, but you also need your suppliers to wake up and say, okay, I don't need 10 grams of silicon carbide powder now. Now I need 100 tons. And then you get a better price, obviously. It's an aspect of building up an industry, and you see that in most or all industrial products, that they become better and better and over time.
Somehow that's also the story of polymeric membranes. I had Graham Pierce on that microphone explaining how when he was visiting customers in the UK in the beginning of the 90s, people were just laughing at him and saying, that thing is just too expensive. It's never going to be used. And then there was cryptosporidium, and then all of a sudden it got used. And the fact that it got used means that more people were using it, so the price went down. So it sounds like somehow polymeric, in terms of this cost curve, has a decade of advance somehow. But now today, if you would have, I know it's stupid, and I know that membrane manufacturer hates that question, but still I have to ask it. If you were to compare it 1-to-1, and let's forget about all the welcome side effects, let's forget about how you're better in OPEX or you're better in everything. Just when you buy it in pure CapEx, what is the ratio today at the same magnitude of size between an equivalent in polymeric membranes and an equivalent in ceramic or silicon carbide membranes?
Again, it depends on the application. So if you can say, to put it in simple terms, when we can deploy our membrane in groundwater treatment where you have very little organic slime that blocks the membrane, you can operate at flux rates that are very, very high, approaching 1000 LMH, whereas the equivalent flux rate for a polymeric membrane would be less than 100.
You need 10 times more polymeric membranes to have the same flux rate.
Exactly, or more. Yeah. And in that case, the SiC becomes the lower cost choice. if you look at it isolated membrane to membrane. But the more slime and organic matter that comes into the water, the lower the difference in flux rate becomes between polymeric and silicon carbide. Because imagine you have more and more slime on the membrane surface, the advantages of and the properties of silicon carbide becomes less pronounced. And it's more the resistance cake layer on the membrane that determines the flux rate. But then you have to look at other things, as I mentioned before, the surrounding equipment, or okay, maybe you can save a DAF, and then it becomes the cheaper option. But in some cases, it is, and in many cases, it is still the most expensive choice, capex-wise. But then hopefully and luckily, there are customers that also look at total cost of ownership over a longer period of time.
On your website, there was a figure which just surprised me. I'm not the biggest expert there is in membranes, so I can be surprised by a lot of things. But I was surprised by this figure, which was saying that if you compare operating costs and energy costs between your solution and the typical polymeric solution, you have 4 times less energy needs. How can you be 4 times better on energy? What is the driver there? Is it, again, this flux rate?
Yes, that is the key aspect to it. And that figure there is from drinking water type applications, a tertiary treatment. The energy is in a membrane is determined by the resistance that the water meets when it encounters the surface of the membrane. The resistance is determined by 3 things primarily. If you imagine the membrane as a surface with a lot of holes, you can imagine if you have a lot of holes as opposed to few holes, there is less resistance. This is the porosity. That's one aspect that provides a high flux rate. The other one is the how hydrophilic the material is. So if the material is very water-loving as opposed to less water-loving, being hydrophobic, there's also a difference in resistance there. And finally, the membrane holes, how much do they bend? How much do they twist? What's the curvature? This is called tortuosity. And on all these 3 aspects, silicon carbide is superior. It is a more hydrophilic material. It has a tortuosity or less twisting in the membrane holes than polymerics and even other ceramics. And the porosity, or the number of holes, is 3 to 4 times higher. So the resistance of the water is much less, and therefore the energy consumption is also much lower, which is one of the key benefits to the OPEX side of things.
What is your oldest plant in operation?
The oldest plant in operation? It is from 2015, so that would be 6 years.
The reason I'm asking is that, a big part of that game is to estimate the TOTEX, so the total cost of ownership over the lifetime of the system. So if your oldest system is 6 years old, what is the lifetime expectancy of your typical system?
Yeah, that's always an uncomfortable question.
Sorry.
No, I'm kidding. But it's always complicated to justify a 20-year life when you only have 6 years of running plants. But we have put a lot of effort into doing extensive autopsies of the plants that we have in operation to determine what is the degradation of the membrane after a certain period of time. Besides all of our internal aging tests that we have done with chemicals and temperatures and mechanical strain internally to see if we can predict the lifetime of the membrane. So that is what we have to go by, and there's a lot of literature and data on polymeric membranes, the true life of polymeric membranes, on the degradation, which is quite well known. So we have that to lean on when evaluating our total estimated life.
I didn't want it to be a tricky question. I'm working for a company which has the best ball valve there was, and there will ever be. So it's interesting for approximately nobody when I say a ball valve. But the characteristic of that ball valve is that it can open and close 100,000 times. And usually the first question you get is, did someone ever open and close it 100,000 times? And in all honesty, beyond the robots that tested it, I'm pretty sure that the answer is no. So I'm not saying that it is so straightforward that if you have just 6 years of history, you can only claim 6 years. I mean, you can simulate an aging and you can have some calculations, but I was curious to understand how you do that. I had Wim Odenart on that microphone from AM Team, and he was explaining how he can fully simulate the operation of a plant. So you could have a plant which behaves like a plant, but was never built. Is it this kind of solution which you're looking at and saying, I could be fully having my digital twin Cembrane system and just check if it lasts 20, 40, 100 years?
So we have used different methods, and we have looked at a long range of chemicals that we know it will be exposed to, and we have done it at a long range of different temperatures. And then we monitor continuously all the characteristics of the membrane, the pore size, the hardness, the morphology, and how does it look in a microscope. We follow those over a long period of time and see what is happening to the membrane in these different conditions. At the same time, we have done miniature plants, lab scale plants, where we are flowing water through and putting this chemical through it and that chemical through it a number of times, while at the same time exerting mechanical stress on the membrane, seeing what is happening there. Because you can focus on one thing, let's say chemical, and see, okay, what happens? But in real life, you're exposed to that chemical, but you're also exposed to a backwash at high pressure. You're also exposed to the sun. You're also exposed to this asset and the other asset. And there's no limit to what an operator can expose your product to, right?
Talking of operator, actually, you explain how you expect your plants or the plants operating with your modules to be easier to operate. But still, let me take a polymeric example. If you take the polymeric example and you're just running too many chemical cleanings and you're very aggressive with the chemical cleanings, well, you're going to just drastically reduce the lifetime of your membranes. Is there anything with ceramic membranes which I can do really wrong and hence kill the expected lifetime of my system?
Yes, obviously, you can break it. It's a good analogy is to, if you go to your kitchen and you look at your ceramic plates, maybe you have some from your grandparents still around. They last a long time, but when you drop them on the floor, they get destroyed. The same goes for silicon carbide ceramic membrane. It is very brittle material. So if an operator, which is something we've seen on a number of occasions, if an operator he drops a hammer or a screwdriver or something on top of the membrane, there can be a chip damage that you would probably not see to the same extent on a softer polymeric membrane. So that is definitely one thing that you need to look out for. So we always try to be very careful and very diligent when we tell them to cover the surface during installation, and when the electricians or who else it is who is standing on top of it, make sure that they don't drop heavy objects on top of it.
Actually, with the design of your module, I guess your membranes are well protected because you have these boxes. So I could imagine that you really have to want to break it to come with a screwdriver and open the module and then try play with the membranes. But still, if you need some commercial advice on how to create some demand.
That's true. No, I think it's the most important thing is to give the customer a good experience when he installs and operates the membranes. It can be a challenge sometimes when things are dropped on top of them, or people are walking on them or jumping on them and doing crazy things. That happens once in a while.
Regarding this CapEx, OpEx, TOTEX question, depending on the market you're in, it can be more or less challenging, I would say, by experience. If you're in the municipal market, usually they have a budget to buy something and a bit less of a budget to operate something. And the industrial world might be the opposite, where they never have any money to buy something, but then operating is just a matter of bottom line. So then you can really leverage this advanced OpEx that you have. Do you still have to educate the market at telling them, look at the total cost, or is it something which is really now entrenched in everyone's mind?
I would say it's much easier now. Maybe you're even convinced now, Antoine, of ceramic membranes and the TOTEX. I think it's easier to convince the engineers, municipalities of the total cost of ownership. But I would say the greatest challenge with respects to introducing a new technology is the risk associated with trying something new. The easiest thing for them is to do what they have always done and to copy things that they know. There's an expression that goes, you prefer the devil you know over the devil that you don't know. Taking risk is not a virtue that is very pronounced in the water treatment industry. It takes time and you need to be patient. But I think the data is there, and when you are presenting the data and the experiences and the references to the engineers or whomever it is, they tend to be convinced of the arguments of ceramic membranes. But why take the risk of trying something new, right? Put your job on the line, or deciding on a drinking water treatment plant is a big decision. Also, a wastewater treatment plant is a very big decision. That's why in the very early stages, we succeeded on the jobs where everything else failed. We went to all corners of the world, and you failed. Okay, let's help you out. You have no other options. Now there's a little bit more options out there.
That's not surprising, because you say that at the beginning it was hard to convince people. Now you start to have a bit more facility because it's no longer this thing which is fully exotic. It starts to exist in the market. And still, if I take out my question from the fridge, you're now working on hybrid solutions and looking at new processes and new things to treat. It's like you want yourself to go back to the position where it's really hard to sell. What exactly are you looking at in this area of emerging contaminants or new ways of treating? Is it process-wise that you're doing something with around your modules, or what do you do?
We don't get involved in process. I was referring to what some of our OEM customers are doing. So we leave the process innovation to our OEM customers to develop hybrid solutions for removing micropollutants or other things. But you're right. You're taking a new product, adding a new element to it, which makes it even more exotic and even a bigger risk to use. And for that reason, it will take even longer time to introduce into the market. That's why it's important to diversify and have a lot of different OEM customers that have different time horizons.
That's my other question to the fridge. I'm coming back to that one. But just to understand here, on the product side, you could be also looking at new alternatives like coating your membranes or combining them. So it's still a product, but it has a new enhancement. Is that a direction which you're looking into? Or do you say, no, that's not for us. We are the specialist of silicon carbide and the module.
We are not looking into that. We see still a lot of work to be done in expanding our capacity, continuously improve the product. And the technology we have is well proven. It works well. And we are finally at a stage where we have a long list of references that are working well, and we can build and grow on that. So we are less prone to making changes, even though we are quite inclined to do it. It's in our nature to jump over new things, but we have to restrain ourselves and focus on what we have now and make this better and keep the industrialization process that we are in with our current silicon carbide product. But there's no doubt there's a lot of innovation potential around that aspect as well. And I keep track of all the scientific literature that is being published, and the number is increasing day by day, which is quite exciting. But we are not jumping over that just yet.
So what does it change for your business model, business strategy, and company future to now be part of Vivo?
Overall, it changes it for the better. We were, I would say, a small company alone, and now we are part of a bigger group.
A small company which were present in 65 countries, right?
Yes, true. Relatively speaking, so we were not publicly listed. We were privately owned and family owned. But now being part of a bigger entity that it's an OEM but based in North America. It means that we have more resources at our disposal. It means we can continue what we're doing, but at a faster pace. So the motivation for us to decide on the acquisition was based on our need for capital, for expanding the capacity. It's quite capital intensive to build a silicon carbide factory. So even though we were profitable, we needed some external funding, and we believed Vivo Skian family was a good place for Sembrine to grow.
Does it mean you're switching gears now in your approach? Because if I get it right, so far you were growing on the bootstrapped approach. You were profitable and you were growing like organically. Now you could have the opportunity to take the market by storm and to simply go to the next scale. Is that your ambition, or do you want to push this bootstrapped approach?
We are growing quite aggressively now. So you might have heard that we are with the Vivo building a big manufacturing facility in Austin, Texas. So we now have a twin of our Denmark facility in Texas that would service the American market.
Is it a direct twin, meaning you're doubling your capacity?
Yes. Obviously, it's not the 100% twin. There are some new upgrades and new equipment that we are implementing over there. That we still have some furnaces from our beginning that they don't have to start out with, but they can deploy the newest equipment over there to begin with.
So you will aggressively go on the North American market. Were you already present there? I guess it must be one of your 65 countries.
Yes, obviously. So we are aggressively expanding our capacity, you can say. Even though I say it's driven by demand and by our pipeline, we I would say taking a more aggressive approach. There's also a lot of new things happening on the marketing side, where we want to take the market by storm. Something that will happen more and more, and you will see in the coming year. A lot of exciting stuff happening on that front as well, that Vivo is helping with. So we will make a big dent and a lot of noise in the markets over the coming years that will hopefully have a very positive impact on our growth trajectory.
How did the deal with Ovivo arrive? Is it one day Mr. Ovivo is just knocking at your door and say, "Hey, are you for sales?" Or did you proactively go to them and say, "Hey," or is it a partnership or something which developed over time?
We had a partnership with them. They were a customer of us almost since the early beginning, and they became minority shareholder in 2018. So we were already kind of in bed together. And around 2019, we saw, okay, we need to gather some capital to grow the company in order to meet the demand for the technology. They were around the corner, and we were looking at different options, but we finally decided that Vivo was the right place for Cembrane to continue what we're doing and to succeed with the vision that we were on. So no, it was I would say something that happened organically, that we still had a partnership going on.
I can't remember the amount of the operation. How big was it?
I can't reveal that amount.
You see how I tried to trick you. I knew it wasn't disclosed, but
I could see it on your smile that that you were trying to. No, but it was the right amount. That's all I can say.
Ovivo is an OEM, right? So that means you now belong to an OEM. Even if I get you will still have your level of independence, but still you have now that vertical link. Did you get some backfire from your existing OEM customers, which said, "Okay, now you're my competitor"?
Not really, and I would say yes. We are owned by Vivo, but Sembrine is still you can say a company with its own management, its own board, and continuing with the same name and with the same strategy. Vivo has been our customer for the North American market for a long time, and the plan is that they are going to focus on that market alone with our products, and we can continue what we're doing outside of North America. So we weren't doing much anyway in North America outside of Vivo. So with our existing OEM customers in Europe, Asia, Middle East, of course, we had to make sure that the message was delivered in the right way and tell them that we continue doing what we're doing. This is a positive thing. We are going to expand our facilities. We have more capacity at our disposal going forward and more resources. but there will not be someone competing with you from within the Vivo family in your specific market. So it has been a plus, and it was a very important aspect to the acquisition that we could continue doing what we're doing, and that's also why that we were attracted to working with Vivo, because they understand the importance of focusing on working with the OEM market.
I was discussing with Wayne Byrne on that microphone. He is the founder of Oxymem, and he exited from Oxymem after selling it to DuPont. And what he was sharing on that microphone is that he started with the end in mind. So he knew why he was building Oxymem, and the reason why he was building it is that he saw a market opportunity, and he believed that he would be, on the long run, exiting to a major, which happened to be DuPont. Was that your case as well? If I go back to, I guess, your kitchen meeting with your father and your brother, when you say, hey, what if we start Sembrine? Was that the end goal, or did it just happen?
It was not the end goal to do that. Our end game was our vision of building this product and industrializing silicon carbide membranes. It wasn't to go public, it wasn't to exit, and it was more products and company focused in terms of growing it. We had a dream or a thought of building a company that could last for hundreds of years, similar to, you might know Grundfos, also a Danish company, a family-owned company. But that's probably one thing that has changed, and that's been a straight line for us. That okay, things have changed, and we were in a situation where we needed capital to grow and to take a bigger leap than what we were able to do. And we saw this opportunity with the Vivo, and we seized it, but still with our end game in mind and respecting our vision.
I guess you see me coming, but what Wayne shared on the microphone as well is that that was his fourth successful exit. So it was like a repeat entrepreneur. And right now he's the CEO of a UV LED company, which means he stayed a bit with DuPont and then he went to his next venture. Can I draw any kind of similarity with your expected future?
I would say I'm quite attracted to starting up new things, but at the same time, I'm also very attracted to being a part of Cembrane and Vivo and building the company and making it the preferred technology for membrane treatment. We are still very, very early. And if we are, let's say, 1% of the market, there's still a long way to go before I can say that we have succeeded with our goal. But so I don't have any plans of starting something new in anytime soon. I have maybe some ideas and dreams of doing something else when I get old, but there are many decades till that will happen.
Between the inception of Sembrane and the moment where it was mature enough to go to this next step and you needed to grow, and hence the move towards Vivo, there's 7 years, roughly. If I take Paul O'Callaghan's thesis on the water technology adoption model, the prediction is that growth takes 15 to 25 years. Somehow, you were 3 to 5 times faster than the average in the water industry. What's your trick to do so?
We took some risks in the beginning. Obviously, we had a lot of experience working with this material.
Can you give an example of these risks?
I would say I call it, we took an innovation through implementation approach. So the companies that Paul probably referenced, they take an approach where they do a lot of lab testing and pilot testing internally for a number of years before they start introducing it to the market. We worked with our OEMs and we took a calculated risk together with our own customers and said, okay, this is the product. We don't really know what it can do. We don't know much of what it can do, but let's try and bring it into the market and see what happens. And we were quite fortunate and lucky that we succeeded installing some successful references very early on. And you need to get references in order to grow your company. If you don't have references, this is a very important asset in the water treatment industry. I remember we got quite a sizable drinking water installation in Sweden. We had no references. We had no experience. We were less than a year old. But the engineer, he had no other option. He couldn't use a polymeric. He couldn't use sand filters for various reasons. So there was only a small startup company from Cembrane. So we did a quick piloting, and for 2 weeks, everything looked good. And then we had to figure out how to, with the help of a consultant, to help get the membranes installed, and everything turned out well. It's still operating, and visited the plant recently, and the customer's happy, and it's all good. So that could easily have turned out very wrong if there were some more complications to the water or what have you, and we could have been in a different place maybe.
So that makes two secret sauces. The first was take risk. The second is build the nice references. So risk, reference, you have 2 R's. If you were to write a book, I think a good title would be like something like 3 R's of success or something like that. So what would be your third one?
I would call it innovation through implementation.
Okay.
So you innovate and develop your product, and you implement it in real life, as opposed to running it in a pilot in a lab for ages.
But you are taking on the water industry, which is probably which is said to be one of the most conservative industries because of that aspect of if something goes wrong with water, it leads to complications. And what you're saying is that you found these early movers which were ready to take the risk together with you and to say, I trust you. So I must say, probably one of the special sauces here is a conviction strength.
Yes, obviously that helps, but it also helps finding some that are sufficiently desperate and have no other options than to take this risk. But obviously they have to be convinced and have a level of trust in you before they send you money.
That's the good old marketing saying. It's that you don't need to have the best product or whatever. You need to have a starving crowd. And they need to be, desperate sounds weird, but at the end of the day, that's what it is. People have problems. And if you're the one to solve the problem, then you have this magical product market fit. And it has not much of magic inside. It's just understanding what is needed. So
yeah, I used the word desperate. Maybe it's a harsh word, but we did have another case very early on in our beginning in Middle East, where there was a particular region that was lacking water, and they tried both conventional technologies, and nothing really succeeded for them. And there were people that needed water, so they were desperate. It was a very serious, life-threatening situation for a lot of people. We came in there and we provided the products, and they took a risk with us, and we succeeded. And one of the testaments to how desperate they were, there were secret police there present during the commissioning phase, making sure everything was done as fast as possible, and making sure if anybody needed any help, they would assist us if need be.
Secret police doing membrane treatment, okay?
Membrane commissioning support.
Well, that makes for an awesome deep dive. So thanks a lot for the openness, Sebastian. I really appreciate that. And sorry for the weird question, but I'd like to scratch beneath the surface, and you didn't stop me, so I could play that game with you. What I propose you, if it's fine with you, is to switch to the rapid fire questions.
It's time for the rapid fire questions.
So in that last section, I'll be trying to keep the questions short, and you can keep the answers short. And don't worry, I'm always the one which is sidetracking. So my first question is, what is the most exciting project you've been working on, and why?
Recently working on developing of our newest version of our module, this SSC Flux FX series. That was very exciting, and seeing it not only being part of the development, but also seeing it being introduced to the market, being used, and solving real life problems is very exciting and very satisfying.
My next question is, can you name one thing that you've learned the hard way?
Building a membrane company, or starting a membrane company, I would say, has been positive, but also a hard lesson, hard work. And when I started, I had a full set of hair. I was often complimented for that. Now it's gone from all the stress that I have had to endure. But at least I have a good face for radio, right? So,
what is the worst moment You mentioned this stress. What's your worst experience?
I would say we at least we have stared over the edge down the cliff many times. You all the time have to look out. Okay, do we have money enough to survive and invest, and what level of risk can we take, and can we pay the employees? And you always have to deal with these kind of things. Okay, now we have an order, and we can survive for this amount of time, and that's stressful. But at one point, when you look over the edge, you start enjoying the view.
But that's probably how you grow 3 times faster than the market. So makes about sense. What is the trend to watch out for in the water sector? And you're not allowed to tell me ceramic membranes.
Okay.
Well, if you firmly believe that the only trend is ceramic membrane, you're still allowed to say it.
No, obviously not. There are so many things happening in different aspects of the treatment side of things. I think for me personally, one thing that is worth looking out for is artificial intelligence or machine learning, or what's the popular term, when the software that optimizes on the treatment plants based on prior data. I think this is quite interesting, and it has already proven that it can do magic in terms of reducing the operational expenditures on wastewater treatment plants and even on membranes. So I think there are some things to watch for there in the future that is quite interesting. That among a number of other things.
I'm not sure how much of a good futurologist I am, and probably not a good one, but that is exactly one of my predictions for next year. I was saying that I expect to have a fully AI run plant operating somewhere, and I'm pretty sure this is going to happen. So I'm glad you support my point.
Yes, definitely.
If you were a world political leader, what would be your first action to influence the fate of the world's water challenges?
I would make myself and my colleagues as redundant as possible, as fast as possible. When we look at the water treatment market, I think we could see a lot more innovation and a lot more advanced and better and lower cost treatment at higher quality if there were more decentralized decision making. And I think having large municipalities deciding on what technologies to use and specifying that, and I don't think that's a very effective way of introducing new products into the market. So I would probably allow for more decentralization and decentralized decision making when it comes to selecting technologies and methods on how to treat wastewater or water going forward. So it would be the boring or the lazy approach, right?
But that's for the decision making. What about the treatments? What do you see in the future? Is it like central treatments, decentralized treatment, distributed, a mix of both?
It's always difficult to answer these generic questions because there is such a difference in the market, right? In Europe, Northwestern Europe, you have treatment plants that are quite well managed and maintained through hundreds of years. And they will probably continue to be maintained very well. Whereas in other parts of the world, you have no infrastructure and infrastructure being built. And here, newer technologies, decentralized technologies are being deployed, I would say, in more and more. I think it's like when you introduce the internet, the more developing nations could go directly from nothing to fiber optics. We had to put in copper and then remove that and then fiber optics.
It depends if you have a legacy, and yeah.
Exactly. Yeah.
Makes a lot of sense. I'm not reopening the debate right now because I don't want you to steal 1 hour. But yeah, when you're looking at the history of the water sector, you look at this, I think it's the Morgan Chase Bank in the US, which was a decentralized water treatment at the very beginning. And then they had too much money, so they became a bank. And yeah, so that's how we started this infrastructure. So somehow it's a return to the roots. So
yeah. I didn't know that. That's interesting.
I have to verify if it was Morgan Chase, but it's Aaron Burr, the one who did all of that. So, but I'm pretty sure it's Morgan Chase. Last question. Would you have someone to recommend me to come on that very microphone to come after you?
A good choice would be Dr. Reinhard Hübner. the CEO of Ski and Water. He's a very knowledgeable guy. He's quick on his feet, and he has a lot of insights to a lot of different technologies and industries within the water sector. So he's a wealth of knowledge. There's also my old friend Kai Gunther Gabriel from Leaktech. He's also it's more on the ceramic side, but he's very passionate and.
I don't want to spoil, but that might happen in January.
Okay. Great minds think alike, right?
Talking about Reinhard Hübner, I've listened to him. I was name dropping Paul O'Callaghan earlier, and I was listening to Paul O'Callaghan's podcast where he was inviting Reinhard Hübner to discuss his thesis, and they had diverging opinions. So that's probably a very good opportunity to get to hear his side of the story.
Yeah, that's a good idea.
Well, Sebastian, it's been a pleasure, such a pleasure that it took more time than expected. You mentioned that you might have ideas. The day one of these ideas becomes true or not true, or you're very thriving at building a monster with Sembrine as a part of Vivo and Skion, that microphone is open to you whenever you want. So, with pleasure.
Thank you. I appreciate it. It was good talking to you, and you've obviously tried this before. So it was my pleasure having this conversation with you, Antoine. I hope to meet you again.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.